Welcome, this is the IM2 lecturing on simplifying expressions with radical exponents, part 2. It's the same learning target as part 1, is for you to understand the radical. There's one new success criteria, it's to convert from the rational exponent to the radical. And also lastly, it's the same thing as before, can you simplify a radical? We're going to review the vocab from part 1. When you see x to the 1/2 power, you can write it as just radical x. The weird symbol here is called a radical. The 1/2 exponent is referred to the square root. So you could see it like this. Right? And you can convert it between this. So you need to be able to go from here to here. And you have to go from here to here. Vice versa. Sometimes you might see it as x to the 1/3 power. Rather than say square, you say cube root. So you need to be able to convert it from here to here, as well as go from the exponent to the radical. But this is what you need to convert from, right? So a short way of thinking about it is the square root is when you just divide by 2. And the exponent divide by 2. But here when it's cube root, the idea is the exponent is going to be divide by 3. That's the idea. Right. Here you want to write the radical expression in radical form. So x to the 1/2 power, we can see that as just radical x, or you could, that's it. No one writes this 2 here. You might want to write the 2 here. No one writes the 2. The 2 here is defaulted, so no one writes the 2. All right. This x to the 2/3 power, this is the same thing as writing 2x squared times 1/3. Okay, that's how you split it up. So the x squared goes inside the radical, and it's a divide by 3, so it's a 3 here. X to the 5/10, we can simplify that to just 1/2 because 5/10 is simple. It can be simplified to 0.5 or in fraction form 1/2. And we can write that as just radical x. What about x to the 3rd? We cannot put in a radical. Why? Because there's no divide by value. It's not being the power of the exponent here isn't being divided by anything. Next, this time we're going to convert from the radical form into the exponent form. So here we saw it is 2 radical y, so it can just be y to the 1/2 power. Right? That's ugly. Let me write it better. Y to the 1/2 power. Next, we have x to the 4. And the radical here is 3, so we just divide this by 3. X to the 8. And it's 4 radical, so we just divide this by 4. This can be reduced down to x. 8/4 is just 2. That's it. Next, x to the 5 divided by 10, which can be broken down into x is equal to 1/2. Right? That's it. Which is, yeah, that's it. You can write it like that. That's all you need to be able to do to convert from the radical to the exponent. All right. So x to the 1/4 power. So it's a divide by 4. So it's 4 radical x. Next, you want to split this into 2 parts. So x to the 3rd times 1/4. So x to the 3rd goes inside the radical. And the divide by 4 is this part. X to the 2 over 4 can be simplified to x equals 1/2. Make sure you simplify the exponent before you put it into the radical, which is just radical x. X to the 5, again, you can't do anything here. So we cannot put into a radical. Let's do this. 5 radical x. So it is just x 1 divided by 5. Again, the value that is on top of the radical is what you're going to be dividing by in the exponent. So the value here, it's x to the 5th. So write x to the 5th. We saw that this is a 7. So we divide this by 7. X to the 15, write x to the 15. The radical is 5, so we just divide this by 5. Make sure you simplify. 15 over 5 is just 3. Next, x to the 0. Ooh, very interesting. This is a very interesting problem because x to the 0 is just 1. Okay? But you can't really do this. This is just really 1. Okay? Given that x is not equal to 0. Okay? No one's going to ask you about 8. 8's just a very interesting problem that I want to throw in here. That's it. This is how you convert from the radical to the exponent, and how do you go from the exponent to the radical. Right? Example 2, we'll just review how to simplify the radical. So we have the square root of 20. If you plug it into the calculator, you're going to get 4.47, which is useless. You have to break this down. You have to pick two values that multiply together to make this number here. In our case, it's going to be 20. A student picks 2 and 10. So they write radical of 2 times 10. We could break it up into its individual parts. A radical 2 times radical 10. We saw that this is bad because we cannot break it down because radical 2 is not a perfect square and radical 10 is not a perfect square. Let's redo the problem now, but let's try to pick a perfect square. We saw here that radical 4 is equal to 2. That looks like a really good number to pick. So radical 20 can be broken down to 4 times 5. Split this apart into its individual parts. So radical 4 times radical 5. Radical 4, like what I circled, is equal to 2. So I just write 2. Do not write radical 4 is equal to radical 2. This is wrong. Okay? Radical 4 is equal to 2. So that's why you write radical 4 became the number 2. Not radical 2. Okay? Look at your chart. And you can't do anything else because the radical 5 is just dead radical 5. This is good because we were able to break down the number in the radical. It was a radical 20. Now it became a radical 5. So that's good. We simplified. So let's look at this. You're going to simplify this into its radical form. Make sure you pick really good numbers that are perfect squares. The square root of 45 can be broken down into radical 9 times 5. So this is just square root of 9 times square root of 5. Square root of 9 just becomes 3. Radical 5 just stays at 5. Next, radical 32. I can pick, let's see, 8 and 4. No. You could pick 8 and 4, but 4 is perfect, 8 isn't. So pick a better number. So I try to use 4, right? But let's try something else. Try 9. No. Try 16. 16 is really good to use. So here, I can write 16 times 2. So this breaks down into radical 16 times radical 2. Radical 16 is 4. Radical 2 cannot be broken down, so we write radical 2. Next, 4 and radical 40. So I can pick, how about 4 and 10? Yeah, 4 is good. I can't use 9, 16. No, 25 is too big, and that's it. Okay, so this breaks down to radical 4 times radical 10. Radical 4 just becomes 2. Radical 10 can't be broken down. If you write 2 times 5, it's useless. You can't break that down anymore. So you can just write this as just radical 10. Next, we have radical 96. And I think radical 96 can be divided by 36. No, radical 96 can be divided by 16. Yeah. So radical 96 can be broken down into 16 times 6. So split this into the two parts, radical 16 times radical 6. Radical 16 just breaks down to 4. Radical 6 cannot be broken down, so it stays as radical 6. Number 5, 28. Radical 4 times 7. So break this down. Radical 4 times radical 7. Radical 4 is 2. Radical 7 is just radical 7. There you go. You're done. Radical 64. Well, look, it's already perfect. So this just becomes 8 because this is already a perfect square. Right? Good. There you go. That's everything that you need to do to simplify the radical. Now, what happens if we throw in variables? So, please understand that this is, remember there's a 2 here. So, we're dividing it by 2. So, break this apart into their parts. So, this is radical 20 times x to the 4 times x y to the third. Okay, hold on. Let me make this a little bit better. Times y to the third. Break this in its 3 parts. So square root of 20 times square root to x to the 4 times square root x to the third. We should already know square root of 20. I think we did that here. We saw that as 2 radical 5. So I'm not going to redo the problem. So 2 radical 5. What we need to notice is what is this? So this is x to the 4. The square root here just tells us to divide this by 2. Give me a moment. So this is 4. And the radical, because there's no number there, it just tells us to divide this by 2. So this becomes just x squared, because 4 divided by 2 is just 2. Next, we have the y third, and it's going to be divided by 2, but it doesn't work, right? So we leave it like that. You can't simplify y 3 over 2. So we just leave it as just radical y cubed. So you have your 2 and your x squared. So it's 2x squared and radical. What's in the radical? You have a 5 here and you have a y cubed here. There you go. That would be your complete answer. It's like before, but this time I just throw in some variables. All right. This should be split into its 2 parts. Radical 45 times radical x squared. We should already know what's radical 45. 3 radical 5. So this is 3 radical 5. And we know that this is x squared divided by 2. So it's going to be multiplied by x. So the answer here, it's 3x radical 5. Here, split it apart. So it is radical 32 times radical x to the 10 times radical y to the 5. So we already know what radical 32 is. Radical 32 is 4 square root 2. So this is 4 square root 2. This is x to the 10. We just divide this by 2. That gets us x to the 5. This is y 5 divided by 2. We can't really do anything, so we just leave it as y to the 5th power. Together, this becomes 4x to the 5th, parentheses, 2, there's a 2 here, y to the 5th. Next, break this apart into its 3 pieces. Radical 40 times radical x to the 3rd times radical y to the 6th. We already know what radical 40 is. 2 times radical 10. So this was 2 radical 10. We saw this x cubed divided by 2. So we can't really do anything. So we leave that the same. Y6 divided by 2. Oh, that becomes y third. Y to the 3rd power. So we can combine this. 2y cubed radical 10 x3. Next, let's do number 4. Break this up into its 2 pieces. Radical 96 times radical z to the 4th. We know that radical 96 was 4 square root 6. 4 square root 6. And we know this is z4. The square root here just says to divide it by 2. So this becomes times z2 squared. So the final answer is 4z squared square root 6. Next, break this up into its 3 pieces. So this is square root 28 times square root z squared times square root y squared. We know that the square root of 28, let's look at our previous problem, was 2 radical 7. So this was 2 radical 7. This was z squared divided by 2, which is just z. And this is y2 divided by 2. So that's just y. So it's 2zy radical 7. 6. Radical 64 times radical x to the 7 times radical y to the 9. We already know that square root of 64 from our previous problem was just 8. So we just write 8 times x 7 divided by 2. We can't really do anything here. And y 9 divided by 2. We can't really do anything here. So it's just 8 radical x to the 7 times y to the 9. You can't really do anything to these because they're odds. But there you go. This is as hard as it's going to get when it comes to simplifying a radical. That's everything that you need to know how to simplify an expression with radical exponents, part 2.